everyone. So I want to try and make this video quick. It might end up being a little long, but this is all about the quadratic formula. So we already talked about how we can find solutions for a quadratic by factoring it and setting the two factors equal to 0. But this is in a case where that's not going to be possible. So the first thing that we have to do is recall the concept of perfect squares. Remember, perfect squares are basically when we take numbers and we can square root them and get a whole number. So a good example are things like this. 1 squared is 1. 4 is a perfect square. It's made up of 2 squared. 9 is a perfect square. 16 and 25. In your notes, I want you to actually write down the rest of the perfect squares. So I believe it goes all the way up to 20. For the most part, you want to kind of have an idea of those 20 perfect squares. Now, if we have non-perfect squares, what we're going to want to do is, because we don't want to have decimals and have to worry about rounding, we want to kind of get actual numbers. So what we're going to do is actually rewrite these perfect squares in a little bit of a different way. So for example, if we had square root of 80, what we would do is we'd find factors of 80 where one of those factors is a perfect square, and we're going to try to find the largest perfect square. So if we fool around with 80 divided by all the perfect squares, we find that the largest perfect square is 16. So 16 times 5. And now what we're going to do is rewrite that square root as the square root of 16 times 5. What we can then do after this is actually take out that 16. So the square root of 16 is 4. And this can be rewritten as 4 radical 5. This is because we can actually split the square root as square root 16 times square root 5. And because 16 is a perfect square, we get 4. There's a few terms for these. For example, sometimes you might see a number that's kind of right here in front of the radical. This is called the index. It tells you the type of radical. For example, if there was a 3 here, this would be the cube root of this number. It just means that you're going to do something a little bit different in the calculator. For the most part, you're going to be dealing with square roots where there's going to be no number. So there's no index number. It's assumed to be 2. Whatever gets left in this radical is called a radicand, and then the number in front is usually called the coefficient. So the idea is that we're going to factor the radicand in order to come up with perfect square factors, and then use that perfect square to create a coefficient. All right. So here's some quick questions. I'm going to skip around. I think I only do 4 of the 10 questions I think I asked. So here's the first 2. Pause video work itself. We'll go over in a second. All right. So what we're going to do here is fool around with this. This can actually be rewritten as square root 4 times 5. Then I'm going to rewrite this as square root 4 times square root 5. Square root of 4 is 2, so the answer is 2 radical 5. You can double check by putting this in the calculator and then putting this, and you get the same number. Over here, do the same thing. The biggest perfect square is 25. And then when we do this, we're then going to have square root 25 times square root 2, which ends up being 5 radical 2. All right. Next to pause the video working itself, and we'll go over in a second. All right. So the 2, we actually still have a coefficient in front of this, so we're going to ignore that for now. The 98 can be rewritten as 2 times 49. So this is going to be 2 times radical 49 times radical 2. Radical 49 is 7, so we end up having 2 times 7 times radical 2. 2 times 7 is 14, so my final answer will be 14 radical 2. Going to this one, as I said, I skip down to number 7, and what I'm going to do is once again rewrite this. 5 times 25 divided by a regular 5. Radical 25 times radical 5 over 5. Radical 25 is 5, so we end up getting 5 rad 5 over 5. So many 5s. These cancel out, and I'm left with just a simple radical 5. All right, so with all that being said, we can now move on to the actual important part, which is the quadratic equation. So recall that we have linear equations where the highest exponent is 1, and the quadratic equations where the highest exponent is 2. And then remember that the standard form of the quadratic is this: ax squared plus bx plus c equals 0. A is going to be the coefficient in front of x, b is the coefficient in front of, a is in front of x squared, b is in front of x, and c is the constant. Remember this. The equation, so besides using the factoring, we could find the solutions by using this quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I always remember this because I remember the jingle, which goes along with Pop Goes the Weasel. So, but that's why you want to remember A, B, and C, and you kind of want to remember to always write your quadratics in standard form. You get two solutions. You get one where you are adding these numbers up top, and then one solution where you're subtracting. So this is what I was saying before. A is a coefficient in front of the x squared, b is in front of the x, and c is your constant. All right. So try using that equation here. Pause the video, work itself, and we'll go over in a second. All right. So what you're going to do is rewrite this equation so it's in standard form. So what I'm going to do is subtract the 7x over to the other side. And I'm going to have 3x squared minus 7x plus 1 equals 0. Remember, it doesn't work unless this is 0. So my a term is 3, my b term is negative 7, and my c term is 1. So the equation, remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I do this, I get negative 7 plus or minus the square root of negative 7 squared minus 4 times, I already said a was 3 and c is 1, all over 2 times 3. Remember, I'm just taking these numbers and plugging them in where I see the letters B, A, and C. Alright, so to kind of clean this up, so negative and negative gives me a positive. So I get plus 7 plus or minus negative 7 squared. When you plug it in, you get 49. Negative 4 times 3 times 1 is minus 12. And 2 times 3 is 6. So from here, I end up getting 7 plus or minus the square root of 49 minus 12, which is 37, all over 6. So my two solutions to this, there is no other way for me to simplify this. This is a non-perfect square that cannot be broken down as a product of a perfect square. So my final answer will end up being 7 over 6 plus radical 37 over 6 and 7 over 6 minus radical 37 over 6. Now, down here I asked, can we use factoring? No. We would not be able to use factoring because there's no way to deal with this type of radical. So we're not getting an integer, we're not getting a number that can be represented as a whole number or anything like that. So this could not have been found using factoring. All right, here's the next question. Pause the video, work itself, and we'll go over in a second. All right, so I'm going to do the same thing. I'm going to subtract the 2 over to this side, and I'm going to add the x squared over to the other side. So my equation ends up being positive x squared minus 2x, and then minus 3 minus 2 gives me minus 5 equals 0. So in front of my a term is 1, my b term is negative 2, and my c term is negative 5. So again, using the quadratic, I am not going to be able to write it out again, but you can follow along on your notes. It's negative b, which is negative 2, plus or minus the square root of b squared, which is going to be negative 2 squared, minus 4 times a times c, all over 2 times 1. So to simplify this, again, negative times a negative is a positive, 2 plus or minus, and then we're going to end up having negative 2 squared, which is 4, and then minus 4 times 1 times negative 5. So this ends up actually becoming plus 20 all over 2. So this is going to be rewritten as 2 plus or minus radical 24 over 2. Now, if I fool around with this, I actually can rewrite 24 as a factor of a perfect square. I can actually write this as 2 plus or minus radical 4 times 6 all over 2. All right, so what this is going to do, the radical 4 is 2, so this ends up being 2 plus or minus 2 rad 6. That's, I can't really factor that any further, all over 2. So I get 2 over 2 plus or minus 2 over rad 6 over 2. These cancel out, and I'm left with my two numbers, x being equal to 1 plus radical 6 and 1 minus radical 6. Because remember, 2 divided by 2 is 1, and this just leaves me with the radical 6. So once again, can we solve this with factoring? No. Because once again, we have a radical in here. There's really no way that we'd be able to solve something like this using factoring. Alright, try this. Pause the video, work itself, and we'll go over in a second. Alright, once again, subtract the 7. We want to get everything all to one side. So 2x squared minus x minus 7. I'm going to try to go a little bit quicker with the quadratic. So a is going to be 2, b is minus 1, c is minus 7. So we end up having negative b plus or minus the square root of negative b squared minus 4ac all over 2 times 2. This will simplify to 1 plus or minus the square root of 57. If you plug in everything that's in here in the calculator, you get 57 all over 4. And again, we can't really break down the 57 any further, so this is going to be written as 1 over 4 plus radical 57 over 4 and 1 over 4 minus radical 57 over 4. And once again, the answer is no, because again, we have we have this radical. All right, last question. Pause the video, work itself, and we'll go over in a second. All right, so add the 3 to the other side. 5x squared plus 9x plus 4 equals 0. So a is going to be 5, b is 9, and c is going to be 4. So using the quadratic, negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is actually going to simplify into something nice. Negative 9 plus or minus the square root of 1 all over 10. So this gets me two numbers. So in one case, I'm going to have negative 9 plus 1 over 10. And the other case, I'm going to have negative 9 minus 1 over 10. Remember, that's what the whole plus or minus is telling us. So in this upper case, negative 9 plus 1 is negative 8 over 10. This can be further simplified by dividing both numbers by 2, so negative 4 over 5. This one, negative 9 minus 1 is negative 10, which gets me negative 1. So my solution set here is negative 1, negative 4 over 5. Now here, the answer of could we solve this using factoring? The answer is yes. We could actually use factoring to solve this because we're getting numbers that are essentially integers, whole numbers or fractions. That's the only way that we could actually solve through factoring. If you end up with a radical, then you would only be able to do it with the quadratic formula. All right, here are the two exit questions. So answer these really quickly. Throw your answers, pause the video. Again, if you have any questions, please let me know. Make sure that you fill out the rest of your notes, and you're going to upload it later on. If you have any questions, let me know on Remind or join the extra help. Otherwise, I'll see you later.